Here we go. We have a question, circle of strings. So you have given an integer array of lowercase strings. We need to determine if the string can be chained together to form a circle. A string S can be chained together with another string Y if the last character of X is the same character as the first character of Y. If every string of the array can be chained with exactly two strings of the array, one with first character and second with the last character, it will form a cycle or a circle. So for example, we have this for geek rig caf. So first we have this, so this R will chain to this, then this G will chain to this, then this K will chain to this, and F will again chain to this. So here we have a chain, or in other words, this is a graph question. We have a cycle. So we have a cycle. So in that case, the answer is yes. So you have given the chain string this. So if the answer is yes, we need to return 1, otherwise we need to return 0. So let's build the approach. As I've already told you, this is a graph question and we are only interested in first character and the last character. The intermediate character are of no use, so we will only look for the first character and the last character. So here we have characters, so it means first we have this, so you can assume it like a tunnel where we enter from A and its exit it from B. So we have an edge from A to B, and second we have B to C, next we have C to D, next we have D to A. So we have characters, but dealing with characters is difficult, so that's why I will deal with numbers 1, 2, 3 and 4. So A to Z, I will give it a number. So let's go 0 to 25. So you can assume it A0, then 1, 2, then 3. So we have a cycle. So if we have a cycle, then only we need to return 1. But we have a edge case here. First, let me give you an idea about this cycle. So if so as we know, this is a directed graph. So we have a directed graph. So let's take this and we can also have a single character. So this is B. So this is only B. We can have a single character also. It means the first character and the last character is same. It also means we have a self edge. So suppose we have this. So now I will tell you a new concept, which is Illyrian cycle. Illyrian cycle means we need to count the edges on every vertex. Here we have 2 edges. Here we have 2 edges. Here we have 4 edges. Why? Because one outside, one inwards, then another outside, then another inwards. So we need to have n even edges. N even means we can start from any edge and end on the same edge. Means we can start on any vertex and end on that same vertex. Suppose I am starting from 2, so I will start from 2, then I will reach 2 again, then I will go to 3, then 1, then 2. So I reached the same starting vertex. So we have a cycle here, so we need to have n even edges, n even edges. Let me give you another example. So in that case, we have three edges here, and here 1 2 3, then 4, 4 here, then 1 2 3 4 5, 5 here. So we have uh, so we have odd edges. So you can start from any given vertex, and at the end you will not reach the same vertex while traversing each and every edge. So that is important here. So if we start from 3, then we again reach 3, then we try to go 2, then 3 again, then 2, then 1, then 2. So this edge is unvisited. So we want to visit each and every edge also. So let me remove this. So here we have 2, here we have 4, and here we have 3. So um, you will not reach the starting vertex. You can do whatever you want, but you will not reach the starting vertex while visiting each and every edge. So let me give you an example. If we start from 1, so we go to 3, we visited this, then we go to the 3, then we go to 1. So this and this is unvisited. So this is not possible to reach each and every vertex if we have odd uh, odd number of connected edges, odd number of connected edges. So we want all the even edges, we want each and every vertex to be connected to even edges. So let me count for this. So here we have two connected edges, here we have two connected edges, here we have two connected edges, and here we have two connected edges. Here I am considering in and out both edges. So if I start from this, then I visit this, then this, then this. It means I started from a vertex, and I reached the same vertex while visiting each and every edge. So that's important thing. So if we have this graph, if we have this graph, we can traverse this. So the first thing, the first step is to have an even connected edges to each vertex. The next important thing, suppose we have this, so this is invalid. Although we have two edges here, two edges here, two connected edges here, and two connected edges here, but we have two separate components. We need only one component, and we want to connect each and every string. So we want to chain each and every string. So at the end we have only one cycle. Here we have two components, so we need one only one component. We need only one component. So if we have a cycle here, if we have a cycle, so you can start from any vertex and you will reach the same vertex, or you will visit each and every neighboring vertices. So first we have this 2, so I will visit this 2, then I will visit this 3, 4, 1, Then if I try to visit 2, 2 is already visited, then I will not visit this 2 again. Means I have visited all the neighbor nodes. So if there is any separate vertex and this is unvisited and there is a self edge, or this is unvisited itself, so in that case what we'll do, we will return 0 because we have two separate components. Let me give you another test case. So we can start from any vertex. So if I visit this, then I will go to first, first of all we need to check the connected edges. So here we have 2, 2, here we have 3. So we have a odd vertex, so this is incorrect. So uh, either I have to build a self edge. So we have 2 here, we have 2 here, we have 1, 2, 3, 4, then 5, 5 here. So let me give you, let me connect with this. So we have 6, 6 connected vertices, 6 connected edges here. So here we have 3. So we don't want 3. Let me connect with this. So we have 4. Here we have 2 and here we have 3. So we need to connect with another, and here also we have 3. So let me connect with this. So here we have 4 and here also we have 4. 4 connected, uh, 4 4 connected edges. So after building this, what we need to do, we can start from any vertex. So if I start from this vertex, let me change the color. If I start from this vertex, then I will visit this, then I will try to visit this. So I will visit this, then this is a self edge, so this is already visited, no need to traverse. Then I will go to this, means this is visited, this is visited. Then we are going in this manner, in this uh, edge. So this is visited. So if I try to visit this, this is already visited. Then I will move to 5. So 3 to 5, this is visited. So from 5, I will try to go 6. So I will visit this, then I will visit this. Then from 8, I will try to go uh, to reach 9. So 9. Then from 9, I will try to go 5. But the 5 is already visited. Then try to go 8. So 8 is already visited. So then I will backtrack, and from 5 I will try to reach 8. 8 is already visited. Then I will backtrack 3 to 9. This is already visited. So I have traversed all the neighboring vertices with its connected edges. So after visiting the graph, so a we have a single cycle here. So in that case it is true. If there is any separate component, if there is any separate component, means this, so this is unvisited, this is unvisited, this is unvisited. So if there is a any vertex which is unvisited, so we will return 0. So that's how we build the approach. Let's code this. So first we need to create adjacency list. Dealing with integer is easy, so I will create a integer urgency list for 26 because we have lowercase, we have lowercase English alphabets, so that's why 26 characters, 26 length will work. Then we need to count connected edges. Connected edges, I am emphasizing on this particular word, connected edges. To every vertex we need to count it. So that's why I have to um, take a dp or connected edges. Then I will need to traverse from every edge. So we have a edge from A to B. I converted this character into integer. So this is a this is A to B. We have a edge from A to B. So A to B. So we need to add A to B because we are considering inwards and outwards both edges. Then we need to create adjacency list. Then we need to check. We need to have all the even connected edges. So that's why we have a Illyrian cycle. So if there is any vertex with odd number of connected edges, so we return 0. Then we need to traverse, or we need to find out if there is more than one connected component or more than one cycle. So we start from the starting character. So I converted this character into integer, and I have a separate function solve passing list and visited array. So I have this function. So this is a simple DFS function where I am visiting each connected vertex. So if vertex is already visited, just return from it, or visit this vertex and visit all its neighbor vertex. So visit all its neighbor vertex. That's all. That's a simple DFS function. After visiting or starting from the uh, starting character, starting from the 0th character, if it visited all the neighbor vertex, so we need to check if there is more than one connected component. So we need to check for all the 26 characters, means more than one connected component present. That's why this component is not covered by cycle, this solve function cycle. So dp of I is greater than 0, means from this particular from this particular vertex we have either inwards or outwards edge. So here we have a character A, C, B, D, C and F, means we don't have X, Y, Z. So this dp of I is 0 for X, Y, Z, means the character is not present. That's why we have either inward or outward edge, and this particular vertex is not visited by the starting cycle, by the initial cycle. So we have a separate component, we have more than one component. So for that case we will return 0, else we return 1. That's all. Let's submit this, and let's talk about time and space complexity. Here we first need to create a graph. So we have a graph, and we have this list and list. So first we are traversing. Let's talk about the time complexity first. So first we are traversing for each and every edge. After this we have 26 length, and then we have a character, and we are visiting one character only once. So the time complexity is order of n. N is the number of edges, or n is the uh, length of the array. Let's talk about the space complexity. So we have a list. So in the list we have 26 characters, and for every character we are adding its neighbor vertex. So we have a graph from A to B. This is a undirected graph. So you can say we have order of n space. and everything else space and dp is constant. So you can say order of n is the space complexity. So we have reached the expected time and space complexity. The code is given in the description box. If you guys have any doubt, feel free to ask in the comment section. Give this video a thumbs up to motivate me and subscribe to this channel. Thank you all for watching.